Hey YouTube, so just got back from a week working at Maker Faire in San Mateo, Bay Area Maker Faire, the biggest and the best. Of course they're all pretty good, but the one in the Bay Area is amazing. I think they had over 70,000 people a day for 2 days or 3 days this year. And I get these cool snazzy t-shirts. I think this is the last year t-shirt, actually. This is a 2014 t-shirt. Got some of the new ones, they're all in the wash. That's what I get. That's how they pay me. I get t-shirts. So I'm pretty cheap that way. But on the other hand, I get to hang around some of the coolest new technology and coolest new ideas on Earth. Oh my God, the fair is so huge, and it's just amazing this year. Anyway, I had a couple days to relax and decompress, and you know, all my wounds are healed. And now it's time to get back to building the Tesla coil. You know, one of the things I noticed about making these videos, though, if you got an idea halfway through what you're doing, you got to kind of edit the video, because a lot of times you set down a path and you're trying to explain to people how they should do something, and then you realize, that's all wrong, and then you stop and reverse. And you know, we're not pros here. We're just a bunch of guys in our garage making these things. So I actually took a couple steps with the Tesla coil that I did not record yesterday, because the ideas came to me as I was doing it, and I wound up having to ditch all the video. But let me show you where we got so far. So what I did was I mounted the secondary on a number of things here. I've got these, you can see them in here. I've got these military, these Navy stanchions. They've got paint on them from some previous thing. I'll have to wash that off. And then I've got some layers of this LDPE that I use for other coil projects. And it turns out that the height that provides me for the secondary is exactly what I need as calculated by a Java TC. So I need an inch between the top of the 3/8 inch refrigeration coil that I'm going to use at the primary, and the first turn here. And let's see, I got to learn how to be a one-armed man like most YouTubers. I don't know if you can see that, but you figure the top will be there. Oh, so, and with parallax, it's a little greater than an inch, but that means I'll have a little bit less coupling, which will prevent the arcing, or rather the racing sparks. You can see on the secondary here, I actually have some damage from prior racing sparks. Now that particular burn mark is underneath. You can see there's a coating on here. There's a nice 1/4 inch at least of a slick coating, and that burn mark is under the coating. Now luckily for me, it did not fuse any of the turns. So the turns are there's still a proper number of turns. I'm still getting 180 ohms total resistance. So I know that this secondary is not damaged, but that's from racing sparks. That's from prior maladjustment of the altitude here. If I had this thing lower, the coupling would be tighter. I'd get racing arcs. There are a lot of theories about what causes racing arcs. I have my own theory, which is that they're standing waves of inappropriate frequency. It builds up voltages around here that arc out amongst itself. Let's see, what else did we do? So I got the secondary on there pretty tight. What I'm going to do is I'm going to have to take this secondary off, and in order to get any of the electronics in here at all, because I'm not going to be able to work by crawling in under here. This is where all the blood and guts are going to go inside there, and I'm not going to be able to crawl in there myself with this back. So I'm going to have to take this thing apart to get the electronics in. But just to show you how that's mounted, so there was a circle, a circle of this red stuff that was left over when I drilled the hole, and I used that, and I mounted the secondary on there. It's with some 1/4x20 studs. What I'm going to do is I'm going to wind up taking this apart, and I will show you all the details. Alright, now you can see I've got a couple of ways to mount the secondary, and one of the downfalls of my particular coil designs over the years is that the secondaries have always been pretty flimsily mounted. I've got a buddy, calls himself Kilovolt, who shows up at Burning Man every year, and what he does is he runs one of these plastic threaded. This is a threaded rod. It's 6 feet long. It's 1/2 inch by 13, and you can get this. I got this at small parts from Amazon. I mean, you can get them pretty much McMaster car. I mean, you're not going to find one at a hardware store in plastic. You'll find a metal one, steel, but that's not appropriate. It's not appropriate to send a steel rod through the center of the secondary. So this is inert electrically. It's 6 feet long. It's threaded. I have a, let's see if I can show you this. So what you're seeing here is this is a weld nut. It's screwed in. The top here is HDPE cutting board that I turned on the lathe. As you can see, the final turn of the secondary comes around here, and then it connects. So I soldered the last turn to this piece of copper, which is hard to solder this. I guess this is 24 gauge wire or whatever to a copper piece. Might have actually had to use a torch to do it. And then this is one of the first secondaries I built. I would probably not do it this way if I was going to do it again. I'd more efficiently, I'd probably just put a copper plate here, because the problem is this wire tends to break. As long as this moves at all, as long as this copper piece moves at all, it'll break off from the wire, despite the fact it's epoxy down there. I use this weld nut. Again, you can get these things at McMaster car. It's a 1/2 inch by 13 weld nut. It's screwed in there with some tiny number 6 wood screws. And then, as I said, there's a plastic, long plastic threaded rod that runs right through the center. And so the idea that my buddy had when he does his Burning Man coils is he runs his rod through the center, and he supports the secondary from the top and the bottom. I thought I'd give that a try, and it enabled me to get an idea to do something else. I'll show you. So the last turn on the bottom here is soldered onto a copper plate. I've epoxied this thing on there to protect it. I don't know. Again, this is one of my first secondaries that I'm reusing here. It's the right size, and this is pretty ugly. I'm going to figure out what to do with that later. But the first turn from the primary, or the last, depending on how you look at it, comes down here. And if we look underneath here, it connects to that copper strip, which is screwed in, and it then goes to this nice brass cylinder that I turned and tapped for 1/2 by 13 yesterday. And I did not film that because I just got that idea suddenly and just did it. And you know, turning brass is kind of fun to watch, but you know, maybe not. In any case, when I take this apart, I'll show you. But this is going to serve as the electrical connection, so that plastic rod comes all the way through the secondary to the bottom here, and then this is threaded onto it, and it's making connection here. So this is part of the electrical connection to ground. So that will come down here, and then inevitably, as you see, I've got a gap there. I got to figure out how to handle. And inevitably, it will appear under here. Let's find the front of the thing. And show up in the ceiling there, coming through there, and that will be the ground connection. And at some point. So that's going to be an electrical connection as well as serving to hold it together structurally. So this bad boy up here goes all the way through, and I'm going to cut this thing because it is 6 feet is way too long at this point. And I might just video that right now. So I'm just going to unceremoniously use my Bosch oscillating saw. You see these things work. Thus, these are wonderful devices. One of the greatest things you can use for home repair. They're great for cutting very low things close to the floor. You can get flush with molding, and I use it for all sorts of things. You can find these at Home Depot. I think it's an item that's about I think it's under $100 these days, and you have to replace the blades periodically. So what I'm going to try to do here is just cut this thing, and then I'll have to chase the threads with a with a die, but let's just cut it here just for the sake of it. My guess is that it'll probably just snap if I, yep. Okay, so that did that. Now I'm going to chase the threads with a die. It's a 1/2 by 13 die. Let's see if I can even get it on there, because I want to be able to. Yeah, it works. Oh, nice and smooth, smooth as silk. This is making it in the new millennium here. Let's see if I can screw something onto that. Here's a weld nut. Let's see if I can screw that on just to make sure the threads are not all wonky. And it is all wonky. Nope, nope. Goes just fine. Okay. So threads are good. Thing is shorter. And now we can move this around without it hitting the ceiling. Away we go. This is the bottom of the secondary here. So what I've got is the first turn comes off the secondary loop, and then it is soldered to this piece of copper plate or copper foil. Actually, it's kind of a plate foil thing. And as you can see, this is the remnants of the way it was when I first built it. This is one, again, the very first serious secondary I made where I coated it and whatever. And if I was going to do this again, I would not just simply solder the last turn onto here. I would make a plate that probably sat this way so that it was impervious to being moved. The problem is if this thing moves, the connection is severed and I have to resolder it. And I've had to do that several times now. So what I did was I resoldered it yesterday, and I epoxied well, I epoxied it a lot, and then I just found this piece of corrugated plastic and epoxied that on there, and that should protect it. I don't think it's going anywhere, but it looks ugly now, so I'm going to have to find a way to cover this so it's not seen. Meanwhile, these things are navy stanchions, and they are simply threaded onto some brass studs I have threaded into the bottom here. So this plate sits atop or is flush with a piece of HDPE cutting board, which forms the lid of the secondary. And so I just threaded it for 1/4 by 20, and that goes into the end of this here. And this is ceramic, and I got this at Surplus Center. I ordered them years and years and years ago. You can find these things around at surplus stores, military surplus. And this is just a brass stud. Now the thing is, of course, with a brass stud, one wonders, am I changing the electrical field environment of the coil? And I think I am. So I don't know how this is going to behave with these brass studs penetrating into the field of the inner field of the coil. I do not know if that's going to change my characteristics any. So in fact, what I've done is I bought some plastic studs, and I'm going to replace the brass with plastic all the way around. Over here, let's see, can you see that? Yeah. This is the bottom of that 1/4 by 20 plastic bit that runs, plastic rod that runs all the way down through the center. Comes out here, and what I've done is to create electrical connection, I turned and threaded this nice piece of brass to form the electrical connection. Now, I didn't have to do anything quite this much in the way of overkill, but I figured it would look cool. It's roughly the same size as these, and so in terms of looks it seemed good. And this will press up against the copper and form the ground. And this is the top of the secondary, and a lot of dust on here. This thing hasn't been used in a long time. So I kind of feebly just screwed in this weld nut. This is the rod that goes all the way through the center. You don't need to do this. In fact, I never had done this before. Again, I have a buddy who goes to Burning Man who secures his secondaries with this, so I thought I'd try it. So the combination of this rod with this at the bottom should form a stiff mechanical force pulling this downward onto the base and giving it some rigidity. Problems I've had with my coils over the ages, I'm sure a lot of people have this, is that these secondaries tend to wobble a lot when they're on their base, and so I wanted it to be pretty rigid. And we'll try you know, threading and tapping into this HDPE. Now this stuff, you know, this will give way. These threads on a 1/4 by 20 aren't particularly deep, and you know, if you yank on it, it's just plastic. It's going to come out. But I figure with 4 of them, with the base solid, I mean, you'd really have to give it a knock to get it off, and you tend to treat these things with some respect when you're using them, so I'm not too worried. This is what it looks like on the bottom as well, and this of course is the connection that comes from the last turn here. Again, you know, very amateurishly done. This is one of my first coils, and at least I know it works. And this is just some LDPE soft stuff. I gotta clean this off before we go much further with the running of the coil, but we're still in construction phase. This is, I put 2 of these on top of each other, gave me 2-inch further height, and that's to provide the correct coupling constant to keep the first turn of the secondary an inch above the top of the primary. So all those dimensions have got to be taken into account, otherwise and things won't work, and you'll have done all this work for nothing. So these I had laying around. I turned these on my lathe years and years ago. These were meant to go in as a top in of a different size coil. This is for a 12-inch coil I built, and this is for 6-inch, I believe, or 8-inch coil I built. Okay, now I have avoided coiling up the primary long enough. I've been sitting here looking at it, thinking about it for weeks, and it's time to get off the pot, as they say. Things to think about with this are, you know, all the pieces of the coil tend to interact with all the other pieces, so decisions I make now about where to drill and how to set up this primary are going to affect how the electronics go in at the end of the day. I really should be putting the electronics in simultaneously with this, but I just don't want to undertake that right now. Here's the, as you can see, here's all the old electronics, just kind of, I won't say they're haphazardly thrown in there. I left a lot of space. I mounted all the wires. These ground wires are floating because they're not connected to anything anymore. But I tried to keep it well spaced. I tried to keep a fan. Let's see if you can see there. Yeah, there's a fan right here. There was an opening here that allowed air to flow in and out, so that there's another fan here on the heatsink for the drive motor. And I tried to keep everything spaced so that it would stay cool. And in fact, for reasonably long runs, it worked fine. After the first fire or two, I did have a couple cases where the insulation on the wires burst into flames. This is all wood. Naturally, it didn't go up in flames. It wasn't the Burning Man exhibition. It was in my driveway, and I was afraid it was going to burn down in my driveway. So I actually was able to put it out with a fire extinguisher, and I relayed everything out. But after the fire, I didn't bother going for looks inside. I just went for function, and I just nailed everything down, and it worked. Now, with this new coil, I want it to look pretty inside and out. I'm probably going to put some LEDs in there to make it look nice. Some of these, the walls of the case right now are PVC. You can't see through it. I'll probably put some clear plastic polycarbonate there. But things to think about with the primary as we loop the primary around, and hopefully it'll work, is that inevitably it needs to connect to some of this number 2 welding cable. Now what I've done in the past is I've just sweated it in there. Open up one of these things, open up the tubing itself, and fashion the copper braid from the welding cable so that it fits into there, and then sweated it like it was a plumbing joint with a torch and some solder. Now, in order to do that, the question is, where will that joint be? Will that joint be up here, outside? Nah, for look's sake, it really should be underneath the surface here. It should be inside. So I'm going to have to run this coil. I'll have to drill a hole. I'll have to run the coil of tubing down through this and then down through this layer here to appear inside. Problem is, when I try to sweat it, it's going to be inside, and this is PVC, and I don't want to start the PVC on fire. So it's almost like what I should do is sweat it outside and then put it in. What I could probably do is pull a piece of this wire up through the floor. That means that the hole will have to be big enough to accept this number 2 cable, which is a little bit bigger than this 3/8. And I think that's what I'll do. I'll bring this up, I'll coil it around, I'll sweat it through there, and then I'll try to bring it down. Now the problem is, though, that if I try to do that, trying to maneuver this after the fact is very difficult. You can't really sweat it here and then, I have to sweat it before it's installed. So all of that's going through my mind right now, and I've been putting it off and putting it off, but in the case of coil building, inevitably it has to be done if we want anything to happen. It won't happen unless we, the builders, do it. So time to do something. Okay, so just a construction note. So I remind myself, remind you, by reminding you, I will remind myself how this works. I set this up some months ago after we built the stanchions. Each stanchion, and there's 6 of them, is set outward from the first one by 4/32 of an inch, which is 1/8 of an inch. So if I add up 6/8, I should get 6/8 is 3/4 of an inch. 3/4 of an inch is the distance between each turn on the stanchion. So there's 3/4 of an inch between the center here and the center there. When I spin all the way around, the first one on this one should line up with the second one on that one, and that's how I'm going to create the spiral. And in fact, if I look here, I've got 1 and 8/32 here, and I've got 1 and 12/32 here, all the way to number 6, which is 1 and 28/32 from the center. So it's a spiral, it's an Archimedes spiral. It's got to be that way. So this is the first one. I arbitrarily picked this one, there's no particular reason. And what I need to do then, because the spiral is going to go this way, it's going to go counterclockwise. By the way, it does not matter if you go counterclockwise or clockwise. Yes, there'll be a different spin or a different orientation of the magnetic field that's created. You remember the right-hand rule, or if you don't remember the right-hand rule, you can look it up. If the current is flowing this way in a solenoid, it will tend to, the magnetic field will tend to point downward. If it's spinning the other way, it'll tend to point upward. It does not matter. The phase will be 180 degrees off. Really doesn't matter when you're building a Tesla coil. It would matter if you were doing radio equipment or something like that, but it does not matter in a coil. I've got this set up for a counterclockwise spiral at the moment, which means that the coil start is going to happen right about here. I'm going to have to drill a hole here. I have to move this, bring this around that way, and it'll end up on the 4th turn. As I remember, we counted for 4 turns. Now I've got enough for 7 turns here, and I will probably put an extra 2 turns on just because I do not know how all this metal is going to affect the field, or I don't know how all this metal frame of this the base, how the little metal studs in the secondary, I don't know how they're going to influence the fields in the secondary. It may change the tuning somewhat, or a lot, I don't know. But what I'm going to do is I'm going to put an extra couple of turns because I've got it. There's no reason to not do it. It doesn't hurt anything if it's unused, and it looks fine. So that's what I'm going to do. So after weeks of precision machining, we're now going to do stuff by eye. And this is where artistry or lack thereof comes in. I've just punched a little starter here, and I'm going to drill. I like that spot. Okay, that's a pilot hole. It's usually better to put tape over this. It stops the cracking on the other side. Now I'm going to try something here. Now put this longer. I want to go straight down through to the bottom. As good as I can get. Easy peasy. Picture me handling this in here. Alright. Let's try to keep it. Get it going. It goes. And our measurements for snapping it in are very nice. occasionally. Look nice. The actual contours are less relevant than appearance. And this I think you get the idea. Not looking too bad, eh? These baby tubing cutters. Go. So one way you can get these things to snap in if they're not snapping in, as you see that one isn't. And what we're going to do is I'm going to find one that's particularly loose, like this one. I'm just going to squeeze it very, very slightly, just to slightly deform it. And now it snaps. Same here. Just needs to be slightly wider. Go. And for appearance's sake, we want this to look even. It really won't affect the electrical performance at all. We want it to be planar. We want the coils to be evenly spaced. And there you go. So now it's time to rock and roll on connecting this to something. Here's the basic effect we're looking at, artistically speaking. Alright, so there's the base. You see the primary coil. I did decide at the end of the day to run it into the box. I figured if I made it long enough I could sweat it outside the box and stick it back in. And there's the toroid. That plastic threaded rod I will cut off. I'm leaving it on there for now because I'm not sure if I need any spare any slack. And you get the general idea that what we've got is the secondary perched on some plastic here with the grounding connection through that brass piece. That should look pretty. Generally speaking, we're getting a nice effect now. And I guess the next step is that I will have no choice but to start hooking up the electronics. I've got to take all of this stuff out of here and put it in here. And this is the I'm going to upgrade to a number 2 gauge welding cable. It's very stiff and difficult to work with compared to this number 4 gauge that I was using here, which is nice and flexible. Didn't really have any problems with the 4 gauge, but I just don't have any left and I don't feel like buying any more. Okay, till next time.